Welcome back to the deep dive. If you've ever gardened, or heck, even just battled a really stubborn weed that keeps coming back,
Oh, yeah.
you know that feeling. You
Yeah.
finally pull out that big, tough plant, look at the nice, clear patch of soil and think, finally.
And then dusted.
Exactly.
Yeah.
But then boom, sometimes just days later, tiny little seedlings are poking right back up.
Yeah.
Same exact spot. It's like,
It's
how?
almost mocking you sometimes.
Right. So today we're doing a deep dive into that exact moment, that little biological mystery of how and why that happens. We're digging into some notes from a really dedicated gardener, we just know them as Ang, who kept meticulous track of this stuff, observing plants, especially tough ones like purple cleome. And Ang documented this exact thing happening. So our mission today is to unpack Ang's big question. What survival trick is the plant actually using to guarantee it comes back right where it was thriving?
It's fascinating because we're not just looking at one survival mechanism here. It's potentially, well, a couple of different strategies working together. Plant resilience in action. This observation, whether it's your prize flower or that weed you hate, it's like a mini lesson in how plants hedge their bets, They plan for things like us coming along and yanking them out.
Absolutely. So let's zero in on the specific event that Ang recorded. They noted pulling out a mature, really established plant from one particular spot.
Right.
Imagine the disruption, right? Roots tearing, the shade canopy gone, soil disturbed. It's a huge shock to that little microenvironment.
Definitely. A sudden change in everything for that catch of ground.
And the result that Ang saw was just startlingly fast. It was reported that almost immediately, we're talking maybe 24, 48 hours, new seedlings were already germinating, starting to grow right on that spot.
Oh, that quick.
Yeah, this sort of aggressive, immediate comeback is what the source notes call continuous germination.
And that speed, I think, is really the key thing. For you as a gardener, or for us analyzing it, it just completely flips the script on thinking, remove the parent, problem solved.
Right.
The plant isn't just crossing its fingers. It's deploying a biological failsafe. It's basically calculated that this spot works, the conditions are good, the old plant proved that, and it needs to reclaim it fast before something else does, especially now the competition's gone.
It's incredibly tenacious, which leads right into Ang's big unanswered question. Where did these tiny new plants actually come from? I mean, it had to start from a seed, obviously, but was it a seed that had been patiently waiting, or one that was like scattered in the moment? Ang actually laid out two competing ideas in the notes, two hypotheses, and they represent really different plant strategies, different timelines.
Okay.
So let's unpack the first one, Hypothesis A. This is the dormant seed idea, sometimes called the seed bank strategy.
The classic seed bank.
Yeah, it suggests these new seedlings sprouted from long-dormant seeds that were already in the soil, maybe for months, maybe even years, just sitting there,
Waiting.
waiting for the perfect trigger.
And in this scenario, the trigger is the removal itself, right? The disturbance. Think about it. That big old plant was casting shade, sucking up water. You pull it out, suddenly, bang. Sunlight hits the soil. Maybe moisture levels change. Even just the physical act of pulling could have woken those seeds up.
Okay, so it's like the plant's long-term savings account. Seeds banked for a rainy day, or maybe a sunny day in this case, an insurance policy.
Exactly. Like an insurance policy. These seeds are built to last, maybe through droughts or freezes, just waiting for that signal. Coast is clear. Competition, gone.
That makes sense. A long game strategy, playing the odds over time.
Yeah, it ensures the species survives even if, say, one whole generation gets wiped out by something unexpected. We're talking seeds with amazing dormancy tricks, staying viable for ages.
Okay, but then there's the other idea. Hypothesis B, the fresh seed model.
The immediate approach.
Right. This theory says the seeds didn't wait at all. They basically just fell off the mature plant as it was being removed. You shake it, you pull it.
And fresh seeds scatter right onto that nice, newly cleared soil.
Exactly. And then those seeds germinate immediately. They jump on the opportunity before anything else can move in.
And the difference between these two is, well, it's pretty fundamental. It shows these two different evolutionary pressures at play.
How so?
Well, hypothesis A, the seed bank, that's patient, defensive. It's survival spread out over time, buffered against disaster. Hypothesis B, the fresh seed drop, that's opportunistic, aggressive, immediate. Survival tied directly to that disturbance event, like Ang pulling the plant.
Okay. But wait a second. If the plant can just drop fresh seeds that sprout right away, why bother with the whole dormant seed bank thing? Isn't the fresh seed approach just better,
Mm-hmm.
faster?
That's a really good question. It gets to the heart of risk management for a plant.
Risk.
Yeah. Think of the fresh seed strategy like an all-in bet. It's fast, yes, potentially high reward, grab that spot now, but it's also high risk. What if the plant detaches all its viable seeds right then and then a sudden frost hits? Or a week-long dry spell?
Oh, right. The whole new generation could be wiped out instantly.
Yeah.
They don't have that safety net of dormancy.
Precisely. So the environment really shapes which strategy pays off. If a plant like this purple cleome lives somewhere with unpredictable weather or short growing seasons, having that dormant seed bank, hypothesis A is crucial diversification. Don't put all your eggs or seeds in one basket.
So the plant is probably doing a bit of both, hedging its bets.
We can likely assume that, yes, especially if Ang is seeing this continuous germination reliably. It suggests the plant has both options available. The real puzzle Ang faced was figuring out which strategy was dominant in that specific moment of regrowth.
Was it the old guard waking up or the new recruits landing?
Exactly. Did the light trigger the old seeds already in the bank, or was it purely the seeds shaken loose during the act of removal?
And this is where it gets really interesting and, frankly, a bit frustrating for Ang, it seems, because they tried to figure this out right there in the garden.
Yeah, boots on the ground observation.
But after watching closely for several days, the notes admit, well, it was just hard to tell. For the gardener standing there looking at these tiny seedlings, they couldn't definitively say which hypothesis was correct.
And we should pause on that because it highlights why this is so tricky in a real-world setting, even for someone paying close attention like Ang.
Why is it so hard? They're just little plants.
Well, you've basically got two potential populations of seeds, the veterans from the seed bank and the brand new ones potentially mixed together in the same square inch of soil.
Okay.
And there are at least three big problems for telling them apart without, lab equipment. First, germination speed. As you said, these tough plants can sprout incredibly fast if conditions are right.
Right. Maybe both types sprout just as quickly.
Could be. Second, the soil itself isn't a blank slate. It's already full of history seeds from previous seasons. Other plants, maybe? It's a complex mix. And third, the very act of removing the parent plant, the disturbance, actually helps both hypotheses. It's the trigger for dormant seeds, and it's the mechanism for scattering fresh seeds. It helps both sides equally.
Ah, I see. So if a freshly dropped seed sprouts in, say, 24 hours, and a dormant seed that just got sunlight also sprouts in 24 hours.
How do you look at that tiny little green shoot and know its backstory? Was it waiting 6 months, or did it literally fall off the parent yesterday?
You pretty much can't, not just by looking.
Not without a much more controlled setup, like maybe you sterilize the soil first, then see what happens when you remove a plant. Or you remove the plant super carefully without disturbing the soil at all. Impossible in a normal garden.
Yeah, you'd need, I don't know, genetic markers or something way beyond backyard observation.
Right, so the fact that Ang struggled to tell them apart, it makes the whole thing very relatable. Nature doesn't always give up its secrets easily.
So the conclusion Ang had to land on was more about the result than the process.
Exactly. Which brings us back to the main takeaway from the notes. The specific mechanism, was it dormancy or fresh detachment? Remains kind of an open question based on this observation alone, but the outcome. That continuous germination happens. That's crystal clear. The plant will come back. It has ways. Plural.
So what's the bottom line here for us, or for you listening, the next time you're weeding that persistent patch?
I think the key thing is just recognizing the sheer strategic cleverness built into these plants, even common weeds.
They aren't just passively growing.
Not at all. They have redundant systems, backup plans built right in to ensure they keep hold of that good spot. They're managing risk, essentially dividing their offspring between patient, long-term investors in the soil bank and aggressive short-term sprinters ready to grab the opening.
So resilience through multiple strategies.
Precisely. And this actually raises a really interesting follow-up question for you to maybe ponder next time you're out there.
Oh, yeah.
Given that Ang found it so hard to tell the difference between the dormant seeds and the fresh ones just by watching, we have to wonder more about those environmental cues.
Like the sunlight and moisture we mentioned.
Exactly. What specific factor might actually tip the balance? Which cue pushes the plant to rely more on one strategy than the other at any given time? Does a really wet, mild spring make the plant think, okay, low risk, let's go for immediate germination with fresh seeds? Because maybe the danger of drying out is low.
Or Conversely, maybe a really dry, hot end to the season triggers it to dump all its seeds into deep dormancy mode, to just wait out the harshness.
Could be. It makes you look at the soil, the weather, the light in a different way. So we'd encourage you. Next time you see that stubborn plant pop back up almost immediately, take a closer look. Try to guess. Is this a patient veteran emerging from the bank or an opportunistic newcomer that just landed?
Yeah.
You might not know for sure, but it definitely makes you appreciate the plant's ingenuity.